All right, welcome everybody to the Friday, December 9th special edition of Kubernetes SIG Service Catalog, where we're going to be discussing API servers. So Morgan Bauer at IBM has been our the head of the spear for this effort. And so Morgan, I wonder if we can start off, if you feel comfortable, basically walking us through what you've gotten done so far. It's not a tremendously huge amount of code, but each line of that is very hard won, since there are no there's nothing around this right now in terms of documentation. So if you'd like, Morgan, feel free to take it away. You have the floor.
Excellent. Let me see if I can do, how do I present my screen, I guess? Screen share. Okay. Sorry. Okay. Is this the best way to do it? Just to do it in GitHub? Does that make sense to everyone?
This is VR for like you're reviewing Morgan's pull requests.
Yeah, excellent. Good, because that's essentially what I want. Because I think now is sort of a basic good time to look at it.
Morgan, can you hide the comments? Because I don't think we need to see all those right now.
How do I do that?
Show comments checkbox.
Excellent. Okay. I guess we might as well start off with the makefile, but this does not look like anything like what the rest of the other makefile stuff looks like, mainly because the original version of this code was built way before we had figured out what we were going to do with the makefiles, and I will, in a follow-up, or someone else who actually understands the makefile will, in a follow-up, refactor this so that it is behave appropriately. But what it does give you is it shows you the main entry point for the command that we're creating, because we're creating a binary that is the server. So luckily GitHub shows us that directly next. More show comments. So what I've done is I have basically cribbed from existing API servers that are out there that follow this sort of new format. One of them being the Kubernetes internal stuff, several of them coming from David at Red Hat. And what you're seeing here is basically my interpretation of what I've seen. It should be familiar somewhat to you if you've looked at those other API servers that exist in OpenShift projects and in Kubernetes itself.
Yeah, so can I just say a word here for those that might be watching on the internet that don't know what an API server is? So what we talk about when we say API server is it's a process that presents the REST API for a set of resources and persists those into some backing storage. We use in all things, as far as I know, in the Kubernetes ecosystem that that have API servers. We use etcd. But basically what it means is it's a REST store with persistent storage attached, and it's the API surface that you actually talk to use an API. So it's a pretty foundational piece of Kubernetes and will be of service catalog. All right, Morgan, back to you.
Yep, no, that's all good information. I'm still new. So basically what we have here is simply a stub that represents what is going to be the output binary. Simple in nature. I haven't gotten to this part yet. This will eventually register our service catalogs API. You can see where I've cribbed this from OpenShift Cube Aggregator. I didn't understand what this meant at the time, but I will explain that in sort of a future meeting, hopefully. And I don't know anything about the logs, so I commented that out until I understand the logs and whether or not we're going to use Kubernetes version of logs or some other decision that we still have to make. Okay, moving on. The important part here is this new command server, which is basically creating, and we'll see the details of it soon, is creating a Cobra command that we then execute. The reason we do this is basically Kubernetes is settled on Cobra. Yeah, everything in there is done through Cobra, and I'm following along with that. And so that's basically the end of this here.
Something else I'll just call out is that CMD top level directory is the convention in Kubernetes main repo for where binaries actually go.
Yep.
So that's why you'll see CMD in there.
Yeah, I think it's partially an offshoot of Go tradition as well. Sort of, if we want to have multiple binaries in our Go repository, then we sub-directory it. But yep, exactly. Is the chat relevant to me? If I pull that up, is that gonna?
No, it's just to point out that Cobra is the command line processor that a lot of people are using.
So Cobra processes the command line flags and decides what function to execute based on either the flags and the sort of subcommands.
Like all things named Cobra, it is less fun than it sounds.
I didn't make any subcommands. Basically, all you're going to see is flags. So, is there any particular questions on this besides, future work for logs and installation of APIs? Should be very simple. Okay. That's the README. We will skip that until we'll come back to it at the end, maybe. We'll skip glide. Come back to that. Okay, so this is the sort of implementation side of the server, and it is in package command server because we're implementing the command server details. Again, that's following the sort of Kubernetes format, and that is up for further review, but for right now, let's have it in here. We're going to be doing some direct stuff with Cobra here, so that's imported. I think we should move straight to the part that I called in the previous function and come back, unpack that. So we have the new command server. So we're going to run, Cobra is going to start up. It's going to set up all the flags, and it's going to run this is going to be the command that runs sort of by default. And then we're going to set up right here below our actual Cobra command. So what we're doing right now is we're going to initialize all of our sub options. So in the terms of the API server, what I've found is they have this pattern of having multiple options objects for different aspects of the server. And we'll go back up to the struct. So the concept here is that there's all these sub options, and each of them is sort of independently configurable. And when you write your own server, you import all of these options and use them individually. But you also sort of expose yourself as an options, and that's what I've done here is expose our own options. And the theory is that any future person can come in and, in theory, take your options object as it exists, and then add their own sub option, add you as a sub options, and configure you, and basically extend it that way versus rewriting everything the whole time. I don't know how that's going to work out, but in theory, that's the idea. Does that concept make sense? So we have the generic, we have the standard runtime options for running the concept of an API server. Then we have configuration for the secure HTTPS certificates, that kind of thing. etcd storage, and authentication authorization. I haven't gotten those to work correctly yet, but this is the basically the start of it. And over time, if you go back and you look through the commit history, basically I sort of started, one thing, then the next thing, then the next thing, and folded them in one at a time, because they are independent. Okie dokie. So you can see when we first start up our command, we basically take the standard setup of each of these options. From what my understanding is, you can dive into it, but they set up sort of the basic defaults such that stuff does not blow up when you run it. I invented this little, I'm not sure exactly the exact format this has to be, but I made I made our incubator service catalog Kubernetes directory.
I have a couple edits to those that I'll comment about, but
Excellent.
Those things that you made do need to exist.
Which part?
They need to exist. You made the right things. I have some minor to apply to them.
Okay. Yep. Good. I figured. I need to know the details of how they need to be formatted, I think. That was my best guess at this point. Future work, still working on it. Okay, so this is where we actually do the Cobra command. When this gets run, it's going to come through and it's going to run this. When we actually run the binary, it's going to run something later further down called run server, which is basically let's run the server. This is where we would also add additional subcommands to do different, if we wanted to have different subcommands, the difference between kube control run and kube control apply sort of a thing. I don't know what that is in terms of a API server, but that's the theory there.
Yeah. So one possible different command that we might have is like an all-in-one mode where you can deploy service catalog, API server, controller, and an etcd all in one thing. But yeah, I don't know that there are a lot of different subcommands for API servers anywhere else otherwise.
Yep. So the next thing is to configure the flags that have come in. I think the order of this section, the order of the Cobra section and the order of this section is not terribly important. It might be in terms of if you define flags here. But anyway, the next idea is we take the flags from Cobra and then it's a data structure of some sort that Cobra uses, and then we give it to all of our sub options, and each of these sub options adds its own flags to that structure. And when we run the binary, you can see that there's a bunch of flags, and you can see that I haven't really defined any flags for our running of the API server, but if you run the API server and you do -- help, which exists, I didn't define it, you'll be able to see all of the flags that these add. And
so that would then,
yep.
So that would then imply that each of those add flag thingies, all those various options, have to sort of coordinate with one another, not to do overlapping flags, I would assume then, right?
Yeah, I think so. I think that's a Cobra thing. Yeah, I don't know. I don't know what happens if there's a conflict. I don't know if the last one wins or if it errors out.
Yeah.
I also don't know the answer to that question, but I think that you do have to ensure that you don't stomp on other people.
Right. And then, so the other question I have is, I just want to make sure I understand, because when you first got into the options stuff, it was, you sort of described sort of a nesting kind of a thing. And I want to make sure I understood that, because from looking a little bit ahead in the code, the way I kind of looked at it was almost like you were subclassing servers, because you kind of implied someone could take your version of a server here and then wrap it in another options thing. And I wanted to make sure that in my mind, I was mentally thinking of it as someone was subclassing your server.
That's sort of that's sort of the theory. I don't think Go has subclassing, so I think
no, it doesn't. I just want to make sure that I was thinking of it conceptually that way, and that was the right way to think of it.
That's kind of how I think of it, but I'm used to OO stuff, so I don't know if that's,
You could build another API server that just wrapped this one and add additional options to it. I think this is good for those that don't know Cobra. And I think we're almost at an end. I think probably the most interesting bits are what happens inside the API server, though.
Well, no, I agree. I wasn't actually focusing on the Cobra stuff. It was more the run server bit that Morgan is going to get to, right?
Yep,
That's the main thing.
Okay.
I want to make sure that if someone subclassed, forgive me for using that word, but they subclassed his options thing to create another server, their run server would have to call Morgan's run server at the appropriate point, right?
I think so. Yeah, that appears to be.
Yeah, unless their run server totally subsumes. Yes.
Yeah, agreed. Okay, so I make sure I'm following it mentally. Okay, thank you.
I would say let's get into the run server section then. So again, we just had that discussion on subsuming and becoming. Yes, that's essentially what I've done. Because at the end I call, run server essentially on the internal server, which I don't know. Okay. So fine. Cobra starts up. It does, the binary starts up, does all the Cobra stuff. It sets all the flags. Eventually, it's going to call run server, and so we're going to get into here. Here's where we actually take some of the extra stuff that was configured by the flags and do a little bit of our own configuration. This is all sort of specific to each line here. So there's sort of three sections. There's the configuration of the options section. There's the configuration of this thing called config. I'm not really sure why it's called that and why it's sort of separate. And then there's the actual running the server part. So move out of the way. At least for the first part here, what I'm doing is I'm just taking, I'm configuring the external address, which is just sort of the host name, from one of the options and giving it to here, and that configures the generic runtime options. Then we set up the self-signed certificates thing, and again, I take the sort of the host name that we've passed in, if you've passed in a host name. So this relies on one of the flags having been set, and if not, it's just basically localhost.
So Morgan, I want to make sure I'm following this correctly. It sounds like in your options, in your server options thing, you defined several properties of basically a server. And what you're doing here is basically running through each one of those various properties and basically calling their do it or prepare yourself or whatever you want to call it type of function, passing in the appropriate data that was passed in from the command line. And that allows each of those various options or properties to get their preparation work done, right?
Yeah, that's pretty much it. That's
okay. Just to make sure I'm following.
It's there's no. The only reason I know to call some of these things is because I've seen that in other code. So I'm trying to figure out. This is part of why we're learning about what needs to be sort of documented. Is call this to set that, call this to set that, and what sort of is necessary to get stuff to run.
Right. Yeah, it's just, simply adding it to a struct doesn't actually do anything. And I figure these series of calls you're doing here is the way of saying, okay, being in the struct is one thing, but now as part of the struct, you're actually going to do something. So this is the way of saying, okay,
Right.
go do it for me now.
Right. This is probably one of the more key functions right here, which is it sets up the certificates if they don't exist, and writes them to disk so that they can be used by everyone else. Or reads existing certificates is from what I understand. Can't remember what this does. We can go into this function later if you want, but this sets up etcd to such that it's ready to talk to it. It doesn't actually try to talk to it or do anything like that, but it makes sure that it has a server to talk to. It knows what port it's on, stuff like that. So this is the set up the actual server part, and we take the generic API server. We say, give me a new config that's unconfigured. Now we pass in our runtime options that does a basic configuration of that config. Then we try to configure it securely. So again, we apply the secure options. So that again configures the standard config to do the certificate secure stuff. This stuff is commented out here because I haven't gotten it to work yet. I'm going to work through that in later stages. But setting up authentication, setting up authorization. Now what we have here is separated out into an individual struct, which is it's very, very simple right now. It's basically sort of just one level of indirection, where we have what is going to be basically our service catalog API server configuration, and that's going to be a separate struct because it's going to be ours. But we're going to again sort of subsume the generic configuration, and that's going to be a part of us. At which point we do complete, and complete basically, from its description, says make sure that everything that needs to be set is set so that we don't crash, and it'll go through some of the other fields and set defaults, and it'll look at fields that exist and sort of create other fields, fill them in from fields that are already filled in. I don't understand the full details of that, but you have to call it, and then you get there's sort of this use of the type system to have a incomplete config and then a complete config. So that's why I basically made a new variable here, because it's a different type. And from that, you do new, you get your server, and then you prepare the server to run. And I don't know the details of this. It does API stuff, and I'm not quite there yet. And then you run the server, and it runs. And there's a stop channel that I probably need to figure out how to, hook into Control-C or something, but that will essentially shut the server down appropriately. And this is junk. So we can go into the generic API server real quick, but that's sort of the, understanding how to, it's very little amount of code, but understanding how to do it has been a challenge, and figured it out. So I've left lots of comments, and I've got documentation.
Yeah, so let me just say again, like Morgan really has been the head of the spear for this. There are very few people that are actually writing API servers using the generic API server bits right now. And part of that is just because we've made certain accommodations like TPR to make it so that you don't have to do this for simple cases. But as we've established in earlier SIG meetings, we need pretty fine-grained control over the REST implementation of this API, which is why we need to write our own. So thank you, Morgan, for being the person that gets to that gets to run ahead of everybody else and jump hurdles in the dark. It is appreciated.
If we have 5 more minutes, we can just look at the API server config that I've started real quick, because it's very simple. It's simply sort of one layer of indirection, but it does show the basic resource. So we have our own struct, which just right now just holds the generic server. We have our own config, which right now just holds the generic config. And then we have essentially a completed version for make the type system happy. So again, in our complete, we call complete on the generic version, and then we do this nice version set here, which enables the version API. So if you do kube control get or kube control version, this will actually respond with content that kube control will print out. We don't actually have any content in here, and so this is sort of a low-hanging fruit if anybody wants to configure the version resource to spit something out specifically. But this sort of just setting this enables that API, which is the one API that is hard-coded into the generic API server, and that's fine with me from a hard-coding things perspective. But adding more APIs is a significantly different manner of doing that. So that's literally the next step, and I've been looking at that today. And you saw earlier we have our new, which returns a server, and you can see that internally all we do is we go to the generic configuration and we call new, and we do a little bit of saving that into our specific struct, and we return that, and then all the other calls pass through to do the run, as you saw later. We call run. We prepare it. I don't particularly. I have this comment here where I don't particularly like that we reach directly inside to do the run, but fixing that is a little bit more roundabout than I thought it would be. So
I appreciate your respect for the law of Demeter.
Yeah, I suppose that's what I'm trying to say. Exactly. There is not much left. I can pull up a server and run through the basic demo if you want, but I don't know if that's worthwhile you can see basically the result of the demo here if you want to go through. The compilation, easy. This needs to be set because if you don't have any etcd server set, you do the validate, it blows up. But you can see that we do have, when we do run it, we do set up a certificate, which is you can use curl, and it will show you this needs to be updated too. We'll show you the output from basic server, but we can also see that kube control will talk to it using our certificate, using our port, and get a response that it is intelligible, and it does not blow up. It does not think, oh, I'm not talking to a Kubernetes server. It knows that, yes, I'm talking to a Kubernetes API server, and I'm happy, and that's pretty good so far.
I like the blank text area.
Yeah, I think I think this is not supposed to be here, but it's just supposed to say, oh yeah, there's a blank line. But yeah, basically this configuration of 6443, that comes from internal automatic configuration based on those options. The server certificate being at var run Kubernetes API server, that comes from sort of automatically configured stuff. So we can see that getting those options, objects, structs, whatever, incorporated into our server has given us a lot of stuff. So I can say that, yeah, it seems to be sort of interestingly designed, and it seems to work out so far. And if you run the server with --help, you'll see all the flags that you can use to configure where the server certificates are and what the sort of host name port is going to be usable. So
So
that
here's where,
covers that, I think.
sorry, I didn't mean to step on your toes, Morgan. I was just going to say, here's where I can probably spend a few minutes showing giving folks on the meeting and those watching on YouTube sneak preview of what this will look like once we have the bits in to actually serve the API. If folks find that useful, it really just takes probably 5 to 10 minutes. I know that Aaron, you've got a meeting in about 9, so maybe that'll be my challenge. Are folks interested in that now, or should we save that for Monday?
Yeah, I'm interested in it.
Okay. Let's see. And of course, it will not find my Sublime window. Bizarre. Okay. I'm going to share my desktop. Can you folks see my Sublime window now?
Yep.
It's a little on the small side, though.
Yeah, and that's actually going to be kind of not great because what I really want to show is in the sidebar. So let me actually go and I'll just show in the terminal where I have some control over the font size. So let's look at, so I know there were, whoops, not great. Also not great. I tell you what, I'm just going to talk for now, which is one of my core competencies, so we should be good. So in Kubernetes right now, if you go and look, and Martin, I see that you've joined, welcome. You're actually just in time because I know there was like kind of a mismatch about this before, and I think it's sorted out for you, but for posterity, let's just go and say, if you look at Kubernetes, you'll see that there is a package called PKG API, and that has some sub packages. Let's go ahead and see. We've got PKG API v1, and what PKG API in Kubernetes is initially in the early days of Kubernetes, there were not different API groups. And so if the main Kubernetes API is basically kind of a grab bag full of a bunch of different things, and you'll also notice if you look in Kubernetes that there's PKG APIs, plural, and that's where we're adding new API groups. So the history of this is that we started out with this one API, PKG API, and that has a ton of stuff in it. It's really hard to mutate that API because it's so wide that you know, when you make a change to it, it can have a ripple effect. It's hard. It's going to be very hard to ever release a V2 of that API. So what we'll probably see is that we'll have new API groups added in Kubernetes to split apart this huge V1 API into different groups. And we're adding new API surface where we can in other API groups, which are basically independent chunks of API that you can evolve at different speeds. So in service catalog, what I think that we'll have, because we've learned the lesson, when I say we, I mean I have personally felt pain in order to learn this lesson, is that we should assume that what we talk about as the API for Kubernetes service catalog is really probably just the first set of things. And we'll probably have another n more sets of API groups that have different facets in them. This is informing my my desire to start with PKG APIs plural in Service Catalog, because like I said, we just found that if you put everything into one, it just gets so big. It's really hard to maintain, really hard to digest. You can't vary different pieces of it at different rates. And finer grained API groups are the solution to that problem. Now, as with a lot of things, if we could go back and design Kubernetes from the ground up again, we wouldn't have PKG API. We'd have PKG APIs, and there'd be a lot more API groups in them for things that are part of the core. And what that would give us is we can evolve them at different rates, and they're smaller, easier to digest, and there's probably n more attributes that folks that know more about the calculus of APIs could tell you about. But from just my simple common folks standpoint as someone that makes APIs, it's good to me to be able to have smaller chunks that you can vary at different speeds. Does that make sense to folks?
Yep. So
It does to me but I've been deep in this for the last week, so.
one question, when you get an API, you have an API call somehow stored in memory as a data structure that exists inside of PKG APIs. When you are ready to store that somewhere durably, in etcd in our case, do you store it as a representation of something in PKG API?
So that's a very good question. Now, just in the last few minutes, I've mentioned the version API. And the concept of API versions is basically that in Kubernetes, when we have an API, there are at least two different dimensions that we can look at it in. There's the versioned one that has so if you look at PKG API v1, or in the Kubernetes incubator repo for Service Catalog, we have PKG API's Service Catalog. So I'm sorry, I'm mixing the streams. So PKG API v1 in Kubernetes is our v1 versioned API. And the PKG API is the unversioned internal API. And what the internal API, what its purpose is to be a neutral API that we can translate between different versions using. And part of what you'll see when I have a better medium to present the layout of the project, of the Kubernetes project on Monday, which I hope will be an agenda item that we tackle, is that part of what exists in a versioned API is generated conversion code to convert that versioned API into the unversioned internal API and back out of. And the idea is that you should be able to have many different versions of an API that are mutually compatible that you can translate between, so that when you've got legacy customers that aren't ready to move on to the new API version that are using v1, that you can host v1 and v2 at the same time, and you can convert between them and program to a single one.
Hey, Paul, is it fair to say that the unversioned API has to be a superset of all the versioned APIs?
Yeah, that's true. You have to be able to convert any versioned API object into the unversioned version.
Cool, makes sense.
So,
And Paul,
Paul, is that a concept that is only for Kubernetes core, or is it something that other are encouraged to follow, like having this unversioned thing and then multiple facets over it that are versioned?
So that's a good question, Martin. That is something that, so let me answer that by way of saying that, like, this is territory where service catalog SIG is sort of like blazing new ground. The only other group that I'm aware of that has made a Kubernetes style API that is public is OpenShift. And yeah, I agree, Morgan. How many times can we say version in one sentence? Many. OpenShift follows this pattern as well, where we have an internal API and a versioned API. In OpenShift, we actually support older API versions that are no longer supported in Kube. Popping a frame off the stack, we're kind of cutting new ground in Kubernetes Service Catalog SIG right now because very few people have done this before. So it will be a pattern that future Kubernetes API authors in non-Kubernetes, not Kubernetes repo, but that have their own API servers do. But it doesn't look like a pattern to us now because we're the second or third instance of it. We don't have enough data points to say, this is something people do all the time because we're one of the first groups doing it.
Okay, thanks.
So here's where I try to get my terminal back open and see if I can. All right, I've got something more concise to show. Okay, so can folks see my screen? Is that a good font size for everybody? Am I muted?
Yep.
Okay, cool. Let's take a look at this because this is a good representative example. So let's forget about, we know that PKG API v1 is not a thing that we'll have. We're going to have PKG APIs, service catalog, and then our first version is going to be v1 alpha 1. So let's assume that we're looking into the future and you're mentally applying a sed command to turn PKG API v1 into PKG API's service catalog v1 alpha 1. So what you're going to see in there is, I'll just go through these in order. This types swagger.generated.go is part of a Swagger API that we generate for all of the different API groups in Kubernetes, and that's actually what forms the publicly visible API documentation. The register.go file is a very small file that registers the actual objects in the API that are resources. And when I say register, it does two things. It says these are the things that are API resources, and then it has a hook that it calls into the API server group registration infrastructure, which I'm totally glossing over for now in the name of time, to say, I want you to present this API. And then, sorry.
Wait, the register.go, is that going to be resource type specific, or do you expect that to be one Go file for all different types?
One Go file for every type in that API version.
So what would be different between, say, our API, our resource type versus, say, core? What would be the difference in that register.go?
The difference is that we have different types. So in register.go, you'll see we're going to register the broker type as an API resource.
Okay, but semantically it's the same thing. It's just different structs in essence.
Exactly. Same idea, different nouns.
Got it. Okay, thank you.
So this ZZ generated defaults is code that is generated to default the state of API resources as they come into the API server. And these are really tedious to write by hand. And so the pattern that we have, and Phil, you might know a little bit more about this or have some complementary information that you can provide, is that we generate defaulting functions. And then if you need to write a boutique one or need a specific one, you put it into this next file, defaults.go.
So how come register.go can't be generated?
You can. Oh, I'm sorry. Actually, I want to say that it may be now, Doug. We've
Cool.
kind of as we have grown the project, gone through and made more of these things generated. So, for example, when I was just a young lad of 2 years younger than I am now, you did not get generated conversion code, and you had to walk uphill in the snow both ways and write your own conversion code. And we've actually turned that into something that is, like, most of the time completely generated. So I'm not sure at this moment whether defaults are generated. It seems like the kind of thing that you should be able to generate to me, but I don't know if they are yet.
Yeah, I don't remember whether those were generated either yet.
Okay. So here's where I need a cheat sheet. Okay, so this types.generated.go is a generated Yamel parser. And for those watching on the internet that may not be aware of this super fun fact, a Yamel parser will parse JSON representations of objects too, because YAML is a superset of JSON. So the reason that this exists is that at some point, I think we found that the YAML parser that we were using, I don't remember which one it was, but it was a hotspot in the API server to do YAML and JSON parsing. So we have a code generator now that will create a custom YAML parser that understands only our API resources and is far more efficient than a generic YAML parser. This conversion test is it's a unit test for conversion code, and I've covered this before, but I'll say it again because it's one of the key points. Conversion is what it sounds like. It's a conversion in both directions, between versioned and unversioned API, so that if you have V1 version and V2 and you need to convert between them, you convert V2 into internal, and then you convert internal out into V1. And this test is just a unit test for that stuff. So types.go is like idiomatic Go file name for the types in a package, and we follow that convention. This generated pb.go is a generated protocol buffers grammar. And for those that aren't familiar with protocol buffers is basically a generation tool for a wire format that is far more efficient than like YAML or God help you, XML. We use in Kubernetes protocol buffers between internal components, but in between an end user and the API server, you will always see YAML, because supporting protocol buffers with end users is something that I don't think anybody wants to do. It's a far more terse format. It's harder to support, harder to debug than it is if you can just get YAML. And I'm going to use my cheat sheet again because I don't happen to know at this point what's in meta.go. Okay, so meta.go is looks to be some functions that are around object meta. For those of you that don't know what object meta is a type. It's not an API resource, but it's part of every API resource that is metadata about the object, like what is this thing's name, namespace if it has one, UID, object version, etc. So we won't see this in our package, but we'll probably see these double-Z generated deep copy and double-Z generated conversion.go. And what those are is those are code generated for deep copies and generated conversions. Again, as I said, a lot of things can just be generated. We basically need custom conversions only where there's something like weird that we have to do for backward compatibility or compatibility with the internal API. And that brings me to the next file in here, which is backward compatibility test.go. So here's my badge of shame because I believe that I'm one of the authors of this file in Kubernetes, and I don't remember exactly why we had to create this, but there was a backward compatibility issue where I think we deprecated fields and we needed to ensure that you could convert back into internal and get them back out in the right way. We won't have that. And since we're using API groups and we can evolve them pretty rapidly, we probably won't wind up having a backward compatibility test, but since it's in there, I'm explaining it. Conversion.go is where custom conversions need to live. So I mentioned that the reason for having a custom conversion is if you have some special case you have to handle, like usually for backward compatibility, you do write your own conversion for those, and they supersede what is in the double-Z generated conversion go. Helpers.go is what it sounds like. We might wind up having helpers, and doc.go I thought was idiomatic for package doc. I've been told that it's not idiomatic and it's something that we do that is stupid, but I think it's cool, so that's my opinion. It's just a very nearly empty Go file that has the package level doc for this, and then defaults test is unit tests for custom defaults. So I hope that is illuminating. We're actually nearly at time. So I'm going to go ahead and probably stop the meeting now. I wonder if we have any questions that we can answer for folks in the next like 2 to 3 minutes.
Yeah, Paul, I'm a little not sure. Which of these files are handcrafted?
Anything that doesn't have generated in the name is handcrafted.
So even doc.go?
Doc.go is handcrafted. In fact,
That's the docs. Yeah, that's the.
so these are the hold on. These are the handcrafted files.
And what's the relationship between these in this directory and in one directory up?
That is a good question that I cannot answer in 30 seconds. Let that be the cliffhanger that we end this meeting at Big Service Catalog on.
Sounds good.
All right, I'm going to stop recording. Thank you all for coming. I hope this was helpful to people.
Yep. Thank you.
All right, everybody have a great weekend, and I will see you all on the internet.
Peace out.
See ya.